These are a couple of boards using the very well-known TPA3255 integrated circuit, and they're actually almost the same, but the difference is this one costs about 90 New Zealand dollars and this one costs about 45 New Zealand dollars, and they're supposed to be, well, they use the same chip and more or less the same circuitry. But which one should you buy? Should you buy them at all? One is clearly half the price, but is it half as good or as good? Or are they both rubbish? Let's have a bit of an in-depth look at these. Now this one looks like it should be more expensive for fairly obvious reasons. It has the connections using these 4mm sockets, which is, in my opinion, good. Certainly made hooking them up pretty simple. I just literally put a 4mm plug in here. These are the speaker outputs, by the way, and this is power input, a nominal 48 volts, and a couple of RCAs or phonos for the input. So that's it, basically that's it. Now, a couple of things you need to know. Although this is clearly labelled positive and negative, both the outputs are floating. You must never ground either of them. If you do, with a bit of luck, its self-protection circuit will work and stop you blowing the processor up. Now, I have actually tried this rather gingerly, just shorting one or the other to ground, and the fault light does go off and it does recover. But it's not something I recommend you doing. It's one of those things that if you're told not to do something, you tend to want to do it, don't you? That can be an enormous error. But in this case, for one brief short to ground, the amplifier survived. But I've done it so you don't have to. This one does implement the output filtering with 2 chokes and 2 capacitors per channel. Whereas the cheaper one, if we just have a quick look to refresh your memory, only has 2 chokes, and yet it's basically the same circuitry. And if we bring them both into camera, the other main difference is the size of these smoothing capacitors, both physically and electrically. Now, they both suffer from the same problem. Only an idiot would design a heatsink to be, for all intents and purposes, touching the main capacitors. But luckily, I say luckily, they're both high temperature working electrolytics. But it doesn't matter how high they are, it's really bad practice to put them anywhere where they're going to get hot, because an electrolytic's life is severely limited. If you're looking at these in 5 or 6 years' time, the chances are you may have to replace these electrolytics because they've dried out. It depends how you implement the circuitry. Now, they do have a heatsink on here, and for normal, when I say normal, I mean average music levels, they get moderately hot to touch, but not over hot. But bearing in mind you're feeling the heatsink and you're not feeling the actual die of the chip, which is where it measures its thermal capabilities from. On either of these, I would suggest you get a little fan, just a tiny one that will sit on the top here. I know this is loose, by the way, it's because I'm going to show you something in a minute. It's not always like this. And it will also keep the electrolytics cool, so it's not a bad idea to have a thermostatically controlled fan that comes on at about 45 degrees and that will keep the whole thing cool, give you more long-term power, because once the die gets hot, it throttles back and the power is limited. Anyway, so that's something that would apply to both of these. You'd be surprised how many variations of these that there are on eBay and AliExpress and others. And the price varies tremendously. Other things of interest, one of the possible issues is whether they're using fake components. Now in the past, this is a buck converter, and it clearly states on here what it should be, and it is actually, well, it's printed what it is, and it's actually an XL7015EI, which is a 5 to 80 volt buck converter. Cuts the working voltage for the preamp here and also some of the other circuitry down to 12 volts. And early versions of this used a lower grade chip, and they were only rated, I think from memory, at about 40 volts, which is fine if you only connect 35 volts to it, but this is designed for 48 volts, so the consequences are this chip used to blow up fairly readily. But I'm pleased to say that they're now using, the actual chip itself, it has an 800 milliamp rating and it's up to 80 volts, so clearly well specified for the job. But it does have a remarkably small inductor. This one here, by the way, is a 3.3 volt regulator, which, as far as I can tell, only gives supply for these two LEDs showing the fault and clipping lights, which incidentally are insanely bright, and I'm tempted to replace the series resistor on them because they're only meant to be an indicator. They're not really designed to heat the whole room. Light the whole room. I think I'll have to edit that out. While we look at this particular one, I've taken the heatsink off. I've wiped the surface clean. It did have a minuscule amount of heatsink compound on there, but I've taken that off because I wanted to try and find out if this was a genuine chip. That's what it says it should be, and that is a genuine Texas Instrument number. But this has no Texas Instruments markings on the chip whatsoever, and there are some numbers on there, and it does actually say on there 3255, and I've actually been in touch with Texas Instruments, and they are extremely unhelpful people. I've tried to contact Texas Instruments, and believe it or not, I had to open an account in order to write to them. So I've done this, and this is my question. I'm testing a number of amplifiers using the TPA3255. How can I tell if the chip is real or a clone? Counterfeits pose a considerable performance, safety and reliability risk. Counterfeiting is a growing threat to our industry. That's why TI strongly recommend our customers to purchase either directly from TI or from an authorized distributor. So clearly they haven't read my note, and I've written back, I appreciate that, but these are already built. I'm just testing them for my YouTube channel. And this is the brilliant supply from their helpline. Due to uncertainties in the supply chain regarding the chain of custody of these products, TI will only support product verification requests from customers who purchase through authorized distributors. All other verification requests must be worked through their supply chain. And I've replied, thank you, that is an amazingly unhelpful. And it just amazes me that I'm trying to help Texas Instruments by warning people not to buy products that may or may not have their genuine chips on there, and they don't give a shit. They're completely unhelpful. Now originally this had a similar kind of plug arrangement here for the power, but the first time I went to put the wires in it, one of the threads cross-threaded instantly and I couldn't screw the thing down. So I've removed that and I've been soldering the wires directly to these terminals here. It clearly states the ground and the 48 volts on here. Now this particular one has blown up and I don't think it's my fault. When I first got this, I took it into the lounge and listened to some music on it, and for about an hour it all worked fine and no issues at all. Then I thought, right, we need to do some measurements on this now to see what it's like, and I brought it into the workshop here and I connected it to my bench power supply with initially 35 volts on it, which is within its capabilities, and it's also a current limited supply, so if something should go wrong it limits the current rather than blowing up. And when I connected it up, bearing in mind at this stage I didn't have anything connected to it except power, and I switched it on and it wasn't drawing any current, and the fault lights, which are normally on, weren't. And I thought, oh, this is weird. And that's when I decided to turn it upside down and see if the voltage was present on these two capacitors, which it was. And I'm sitting there looking at it and it was drawing about 2 milliamps, which is somewhat less than the rated quiescent current. And as I'm looking at it, all of a sudden there was a click and the quiescent current of 2 milliamps went up to half an amp when the power supply limited, and we got the burny smell from somewhere in this area, and I suspect it's possibly this regulator. I don't know, but this particular amplifier is no longer a functioning unit. So let's put that to one side. Now this one has a physically much bigger 12 volt regulator, and it's a completely different number. It's an LM257 HV-12. The 12 denotes the supply of 12 volts. And the HV, again, this was also a source of discussion on various forums, that initially they fitted a lower value. In other words, they didn't have the HV designation, and it was initially limited to 40 volts, and the consequences are they used to pop fairly regularly. But now they've replaced it with the HV-12, which is designed for up to 60 volts, again well within the rating of the maximum of 48 volts. So basically, if you buy one of these type of modules that looks like that, make sure it has the HV-12, then you'll be safe. And it also has a bigger inductor here, and it still uses the same 3.3 volt chip with insanely bright LEDs on there. Now the chip on this one, I haven't got it apart right now, but it is different from the one on the other channel and does have the Texas Instruments logo on it. Now granted, that doesn't mean Texas Instruments made it. It just means if it is a fake, it's being copied more convincingly, shall we say. I don't know really if I have a conclusion about these or not. I've been listening to it quite comprehensively since I last reviewed this, the bigger one of the two, and it does have some very likable qualities, and providing you're not naive enough to think it's a 300 watt amplifier, because it isn't. In real terms, into an 8 ohm loudspeaker, possibly more into, well, it will be more into 4 ohms, but I haven't tested it into 4 ohms yet. You will get about 65 watts, genuine watts, just prior to clipping with a 48 volt supply. And if you do that and you keep it well ventilated, and unlike some of the suppliers on eBay who put it in a sealed box, can you believe, with the heatsink actually inside the box? I mean, that is insane. It will just get so hot, you'll probably be down to, I don't know what sort of power, but it will overheat, and all that heat's going to be transferred to those capacitors, and the inside of the box will get very warm. So its life would be comparatively less. So my advice is, if you're going to have one of these, don't put it in a silly enclosed box, and to make it really worthwhile, fit a little fan on it with one of those little regulators that I've shown you in the past, which cost pennies, and then you will have not a bad 65 to 70 watt amplifier. And it does sound pretty good, and for the price, well, talking about price, should you buy the cheap one or the more expensive one? And I saw one on there earlier today which was $118 New Zealand dollars, and I still can't really find out why, because some do the trick of making the product cheap, but then they charge $25, $30 for postage. So obviously you need to look at the whole picture. You need to know the price, including your local tax and everything, because the price you see on there is not the price you pay. A $45 amplifier could end up costing you $70 time you pay postage and local taxes. So it's not quite as brilliant as you think. Now, regarding voltage, Texas Instruments do say you can put up to 53 volts on it. I've not tried this. I'm not brave enough, because it's like anything, you never want to use it at the maximum, because if it creeps up half a volt, does it go bang? And if it does, whose fault is it? Your fault, because you've put more volts on it. So in all honesty, 48 volts would be the voltage I would use maximum. And check the regulators on there are the correct ones, because whether there's still any old stock around, but if you do that, it will blow up. Guarantee it, because you can't put 48 volts on a 40 volt maximum regulator. I mean, that's quite a big overload, isn't it? On this big one, they're actually using a very small TPA3255, which is not known for its low noise. They tend to be a little bit hissy, but this cheap and cheerful one uses 5532s, and they're on sockets, so you can change them, which is what you need to do, because guess what? They're fakes. So although I don't know whether they're fakes on the 7.2, because I don't know of a way of testing them other than the fact they're miniature and they're soldered straight on. But theoretically, a genuine 5532 is going to be better than the TPA72 for noise, if nothing else. But if they're putting fake chips on here, it makes you wonder whether the whole thing's fake, because as I said to you, it's half the price, but you're getting smaller caps, smaller chokes. If you just want something that's as cheap as possible, then the little one will probably be okay. But I would restrict personally the voltage on that to about 35. You'll be down to about 35 watts per channel. But if that's what you need or is adequate, go ahead and do it. I'd be interested if any of you good folks have built, or not built, you wouldn't want to build one of these, if I've purchased any of these types, and leave a message on there as to what you feel about it. The price you paid, and not necessarily where it came from, but certainly your experiences. Do you like the sound? Did it go bang? Just tell us what you think, because if you're watching this video, then obviously it's something that you've been thinking about, whether you should go Class D or not. For me, the L12 is still a better amplifier, and I wanted it to be good, but it's not as good as the L12. We won't go into that because it's not a review comparing them, it's just basically an update. Anyway, everybody says at the end of their videos, subscribe and click the button. Well, that's entirely up to you. I would like you to be a subscriber, obvious reasons, but I'm not going to push you to press the button. If you don't want to do it, don't do it. I don't care. But everybody else seems to be doing it for some reason. I'm not sure. Perhaps I think it must be something to do with YouTube's algorithm. If lots of people press the button, it gets on the recommended list, and it means instead of making 0.1 cent per view, I might make 1 cent. Press the button.